So welcome to this session. In this session, we are going to discuss the results and solutions of the cartoon that we did on 29th November 2024. I encourage you to go through the solutions and correct on the mistakes that probably you made, so that during the final exam, you may have an easy way of answering and responding to the problems. So I'll start by going directly to the summary of the results. So these were the results. So the class has 586 students, but out of these 586 students, 49 didn't do the cut. So the summary of the results that were obtained is mean is 58%. Majority of students, the median is 60%. Most students scored 48%. And we have a standard deviation of 15.58, and these are the statistical variables. So we can clearly see that the class performance was above about 50% mark. So which means that the class fairly performed well. This is a simple histogram representing the result. So as we can see, majority of students scored between 50% and 78%, which is a good result. And we can actually have an improvement of this result if we work hard for the final exam. So this is the overall performance. 144 students actually managed to get an A, so which is from 70 to 100%. The highest score was 90% by two students. Abdi Hawa and Musioki Lucy scored 90%. Then we had 88, Tracy Owino, Shira Neema, Sahara Dakat. And then we had 86, Marigot Mtindi John, Grace Wairimu Kenubia. And then we have Amida Isa. And there are other several students who also performed very well. You can see from the list. So these are a combination of the two groups, Bachelor of Science in Economics and Bachelor of Science and in Economics and Statistics. So we have this as the results. So I hope you can see your name if you are in this A bracket. So I've gone further to split the top results or the top performers for each of the two groups. So in the Bachelor of Economics group, the top performer was Amand Isheja Krio, who scored 84%. We also had Gadhirwa Kimberly, also 84%. Boreso Lemale, 84%. And then we have Oziambo Melvin Anyango, who scored 82%. We have Collins Ocheng Kabaka, 80%. Doris Robbie, 80%. Juma Ocheng, 80%. Stewart Waruthi, 80%. who scored 80%, Stewart 80%, Charlo Mary 80%, and these are other performers, top performers. So you can clearly see if you are on this bracket list. And then the Bachelor of Economics and Statistics for top performers. So the highest scored 90%, and there are two of them, Abdi, Musyoki. Then we have Tracy Owino, who scored 88%. We have Washira Neema, Sahara Dakat, Marigot Ret Mutinti, Grace Wairimu, Nyango, and several others who scored high marks. So you can see this. So comparatively for the two groups, the Bachelor of Economics and Statistics posted higher number of A's than Bachelor of Economics because this group had 93 A's, while Bachelor of Economics had 51 A's. Overall, the performance was good, but we can still improve and get higher marks than what we have here. So let's go next to the solutions. So the first question was, in a survey conducted among 360 students, a researcher sought to determine the preferences for various finance-related courses: personal finance, corporate finance, and investment analysis. The following results were obtained. 18 students studied all the three courses. 171 studied personal finance. 138 studied corporate finance. 155 studied investment analysis. And 29 did not study any of the three courses. So based on this information, find how many students studied exactly two of the three non-related courses. So when you're given such a problem, which is testing on application of on sets or counting problems on sets, it's advisable to draw a Venn diagram. So we start by letting P to be the set of students who study personal finance, C, those who study corporate finance, and I, investment analysis. And so this is the structure of the Venn diagram. And then from this Venn diagram, these parts labeled A, B, and C are the parts which, like part A, are those students who study exactly personal finance and corporate finance. B, personal finance and investment analysis. And then this part C, those students who study corporate finance and investment analysis. So the question we need to respond to, find how many students study exactly two of the three related courses, are the sum of these students who are in A, B, and C. And we are told that 29 did not study any of the three courses, so you put 29 outside the three circles. So we know that now, given the total as 360, then with these 29 who are not studying any of the three courses, so to get the number of students who study at least any of the three courses will be total minus this 29, which is 331. Then using inclusion-exclusion principle for counting, we know that the union of three sets is given by the sum of the cardinality of the each of the three sets minus the intersections of the pairs, and then plus the intersection of all the three. This is the inclusion-exclusion principle. So replacing in the values, we have this, where 331, when we add all these other values on the right-hand side, and then collect all these unknown terms A, B, and C, put them in brackets, so A plus B plus C, then you rearrange and simplify the expression, you'll get that the sum of A plus B plus C is 97. And that is the required result because when you are in A plus B plus C, you'll be counted to be exactly studying exactly two of the three courses given. So the answer to that problem is 97. And these are the marking points. Then question 2 was 65% of students participate in extracurricular activities and 75% are involved in community service. So what percentage of participants participate in both? So this problem here, we let E to be those students who study in extracurricular activities and C to be students who participate in community service. So we have not been told that none of the students in the survey, no student actually in the survey actually is not studying any of the two activities. So which means then that the total percent, which is 100%, is the union or the total number of students, and each of them must be participating in at least any of the two activities. So using inclusion-exclusion principle, then we have the cardinality or the percentage of the union of the two activities the same as percentage of the first activity, extracurricular activity, then community service, and then man of intersection. So replacing the values accordingly, then we get that the cardinality of the percentage of the intersection is 40%, which is actually the question or the response that we are looking for as those who participate in both activities. So 40% of the students participate in both activities. Then C, we have been given set A, we have been given set B, we have been given set C, and we have been asked to find A union B intersect A union C. So the first thing you do, you define A union B, which is simply all elements in A or in B. Then A union C, all elements in A or in C. So this is the union. And then we now define the intersection of these two sets, A union B and A union C. And we clearly see that this will be the elements which will be in that intersection. Then part B, A intersect B, Roman 2, A intersect B, union A intersect C. First define A intersect B, which means elements which are common to set A and set B, which are defined by this. And then A intersect C means elements which are common to A and C, which is given by this list. And then the union of A intersect B and A intersect C means now we take all these elements together, these are the elements. Remember, repetition does not create new elements. So once you have written an element from this first list, you don't have to repeat. Like 4 is written, then when you are writing the whole list, you don't write 4 twice, just write once. Then A minus B minus C. First define B minus C, which simply means all elements in B which are not in C. So elements which are in this set, not in this set, are 3, C, Y, 5, D, and M. And then once we have defined B minus C, then A minus B minus C means all elements which are in A but not in this set difference of B minus C. And you can clearly see that this is the list of elements which are in set A, but not in this other set. And this is symmetric difference of A and B. So symmetric difference of A and B is A minus B union B minus A. So A minus B is given by this list. B minus A is given by this list. So therefore, when you combine these two, you get the symmetric difference of A and B. Also, similarly, note that A symmetric B can as well be defined as A union B minus A intersect B. So check that if you get this list of A union B and then you define A intersect B, if you subtract this list, this set from minus this set, A union B minus A intersect B, you'll still get this set A symmetric B. Then the next question was, given that 3 plus I is a root of the quadratic equation 2z power 4 minus 3z cubed minus 9z squared plus 120z minus 50 equals to 0, solve the equation completely. So when you are told that 3 plus I is a root of any given polynomial equation, then obviously the conjugate of that complex number is also another root. So what we do, we write this, remember now, because 3 plus I and 3 minus I is a root. So when we have 3 minus z minus 3 plus I is a factor of this left-hand side of this equation. Similarly, z minus the conjugate root 3 minus I is also a factor of this left-hand side of the equation. So this is why we are having z minus 3 plus I times z minus 3 minus I. So when you multiply these two, we get a quadratic expression. And because we have a quadratic expression on the left-hand side, so we need to multiply by a quadratic term so that we actually have the two sides to balance. So where A, B, and C are unknowns to be found. So what we do now, we expand the right-hand side. And then when you expand the right-hand side, then this is what you'll have. After expanding the right-hand side, then you equate corresponding coefficients of z power 4, z power 3, z power 2, z, and the constant term. So when you equate, you find that the constant A is 2, and then B minus 6A is the same as minus 3, which is the coefficient of z power 3 on the left-hand side. So it tells us that when you replace A for 2, B minus 12 equals to minus 3, this gives you B to be 9. Then C minus 6B plus 10A is the same as the coefficient of Z squared on the left-hand side, which is minus 39. So we replace the values of A and B from step 1 and from the previous steps. We get C minus 54 plus 20 equals to minus 39. This will give us C as minus 5. And then the constant term is minus 6C plus 10B. Then the constant, this will give us, of course, the coefficient of Z power 1, which is 120. And then when you substitute the values previously obtained, we get a value of C, which is actually going to give us minus 5. Then, so it means then that we, this given quadratic expression on the left-hand side of the equation is the same as this product of these two quadratic expressions. And now, if we equate this to 0, then it means that we can easily solve each of the two quadratic parts. And so this other quadratic part using quadratic formula, the solution will be minus 9 plus or minus 11 over 4, where one of the roots will be a half and the other root will be minus 5. So therefore, the complete solution will be Z is 3 plus I, Z equals to 3 minus I, then Z is a half, Z equals to minus 5. So show that the points 1 minus a half plus I root 3 over 2 and minus a half minus I over minus I root 3 over 2 are vertices of an equilateral triangle. So we take these complex numbers as points in the complex plane. So let this one to be A, this other complex number to be point B, this other complex number to be point C. So to show that the points form an equilateral triangle is simply to show that the distance of this distance from A to B, B to C, C to A have uniform length. So this reduces to a problem of solving the modulus of length of the difference between these complex numbers in pairs. So the modulus of the difference of A and B, if the A and B are complex numbers, is given by this formula. So A is this, B is given by this number. So when you find the modulus of length of A minus B, we get root 3. Similarly, when you get the modulus of B minus C, we get root 3. And when you get modulus of A minus C, it's also root 3. So because these three distances have uniform length, or actually all of them are uniform root 3, then we conclude that the points form vertices of a equilateral triangle. Then in a survey of 33 constituencies in Kenya, researchers surveyed whether these constituencies had professional soccer team, a professional rugby team, or a professional basketball team. The following information was determined. 5 had all the 3 teams, 11 had soccer and rugby, 7 had soccer and basketball, 9 rugby and basketball, 16 had soccer, 17 rugby, 15 had basketball. So create a Venn diagram to model this information. So you let S to represent soccer team, R to represent rugby team, B represent basketball team. So this is the Venn diagram. So the first thing, because we've been told that 5 had all the 3 teams, actually that's why we fix 5. And then from the information given, you can actually find the values of each of these portions of the Venn diagram. So this is the desired Venn diagram. And then from the Venn diagram, how many constituencies had exactly one had only rugby team? So from this diagram, you can see that this part is where you'll only be in set R. So the answer for that part will be 2. How many constituencies had soccer or rugby? So this simply the cardinality of union of S and R. Remember, the word or is the key definition in the union of sets. So the union of S and R will be given by this using the inclusion-exclusion principle. Then, or you can clearly count the sum of elements 3 plus 2 plus 5 plus 6 plus 2 plus 4, you get the same answer if you don't want this principle. Then, how many constituencies had both soccer and rugby but not basketball? So you need to be in the intersection of S and R, but then you should not be in a part which will be counted to be in B. So S and R intersection is this part with 6 and 5, but then this 5 is in B, so only 6 is the required part. Then how many had exactly 2 teams? So from this Venn diagram, exactly 2 teams means you are here in this portion of 6, this portion of 4, or this portion of 2. So when you sum them, you get the required solution, which is 12. Then next question, given that -1 is a root of this cubic equation, find the value of k. So when we say -1 is a root, then it means that when you replace z equals to -1 into the equation, then the equation is satisfied. So we simply replace where the z by -1 and simplify. So -1 power 3 minus -1 squared plus 3 times -1 plus k equals to 0. Then simplify and you get k to be 5. Find the other 2 roots of the equation. So to find the other 2 roots of the equation, now you fix the correct value of k, which is 5. So this is the cubic equation, z cubed minus 3 squared plus 3z plus 5 equals to 0. Then we can either use long division or use synthetic division to actually find another factor of this cubic equation, because we have already known that z plus 1 is a factor, since z equals to -1 is a root. So you divide by synthetic division, or you can as well use long division, z cubed minus z squared plus 3z plus 5 by z plus 1. And then you get that this will be the quotient. So which means this cubic expression can be factored as a product of this quadratic expression and this linear expression. And it's now very easy to solve this equation because the quadratic part can be solved by quadratic formula. So using quadratic formula, we can solve this quadratic equation, and we get that z will be plus or minus 2i. So the complete set of solution will be one root is z equals to -1, the other one will be 1 plus 2i, the other one will be 1 minus 2i. Now, next one, find the negation of the following statements. 1, supply is greater than demand and prices are stable. So this question, majority of students didn't perform well because it was testing on the negation of the conjunction of 2 statements. So here what you do is split in 2 parts to clearly see the negation of this given statement. So let P be the supply is greater than demand, the first statement, and Q be prices are stable. So this statement now symbolically can be written in this form. And remember that the negation of P and Q is the negation of P and Q is the same as not P or not Q. So the negation of the first statement, supply is greater than demand, is the same as supply is not greater than demand. The negation of Q, prices are stable, is prices are not stable. So therefore, the negation of the given statement P and Q will be given by supply is not greater than demand, or supply are not stable. And just now, I've done this table. This is not part of the solution, but just to actually to help you understand why we are saying that the negation of a conjunction P and Q is a statement not P or not Q. So if you can check in this Venn diagram that if this P, this Q, this P and Q, you negate P and Q, you get these are the values. Negation of P, these are the truth values. Negation of Q, these are the truth values. And if you are to now create the column for not P or not Q, you clearly see that this column for not P or not Q is exactly the same as the column for negation of P and Q. So note that the negation of a conjunction P and Q is the same as not P or not Q. So this is the solution for that. A majority of students never got the had problems here. So ensure that next time you don't get it wrong. Then part B, if a country's GDP grows, then its unemployment rate decreases. This is an implication of conditional statement. So what you do, split it in two parts. So let the P be statement, a country's GDP grows. Q be the statement, the unemployment rate decreases. So the statement can be written in this way symbolically, and know that the negation of a conditional statement is the conditional statement P implies Q is the statement P and not Q. So therefore, the negation of the given statement will be a country's GDP grows and its unemployment rate does not decrease. Also, majority of students never got this one right. They were writing, if a country's GDP grows, then it's if a country's GDP does not grow, then its unemployment rate does not decrease. That is totally wrong. So immediately I say your answer starting with if, then I know that you are wrong. So the negation of an implication P implies Q is P and not Q. And therefore the negation does not start with if. It starts with the P statement followed by and, then you negate Q. So just to appreciate that, you can also clearly see that if you draw the truth table, this P, this Q, P implies Q, these are the truth values. If you negate this statement, which is the solution we need to get A, these are the truth values, and which are actually similar or congruent to the truth values of P and not Q. So note that the negation of P implies Q is a statement P and not Q. So when you are writing the answer for negation of P implies Q, your answer can never start with an if, since this is just now a conjunction, not a conditional statement. So with the help of a truth table, prove that not P and Q is equivalent to not P or not Q. So you draw the column for P with these truth values, column for Q with these truth values, then define P and Q, whose truth values are given by this. Then negate this column. Negation of T is F, negation of F is T, and then you have these values. Then define the column for not P, column for not Q, then combine these two. So F for F is F, F for T is T, T or F is T, T or T is T. So these are the values for not P or not Q. These are the values for not P and Q. We can clearly see from this table that this column is a photocopy of this other column. So then you write the statement that from truth table is very clear that this column and this column are identical, hence the two statements are equivalent. So this statement is not fashion, it's part of the solution. You must always write it for you to have completed the solution to show the equivalence. So write the converse, inverse, and contrapositive of the following statement. If prices increase, then demand will decrease. So what you do, split this conditional statement into two atomic statements. So let P be prices increase, first statement, Q be statement, demand will decrease. And now for us to define these three statements, converse, inverse, and contrapositive, we also need negation of these statements P and Q. So negate P, negate Q. So the given statement, if prices increase, then the demand will decrease, can be written symbolically in this form. And the converse of P implies Q is actually the swap, that the second statement becomes the first statement. So the converse means converse of P implies Q is the statement Q implies P. So when we reverse, then the answer becomes, if demand decreases, then prices will increase. That will be the converse. So converse statement means first becomes second, second becomes first. Or you change the order. What came first becomes last, and last becomes first. Then inverse. Inverse of the statement P implies Q means you negate P and negate Q, and so the statement will be not P implies not Q. So here we'll have, if prices do not increase, then demand will not decrease. Then contrapositive, now you swap the order of the statement in the inverse, so it becomes the converse or the contrapositive of P implies Q is the statement not Q implies not P, which will be if demand does not decrease, then prices will not increase. They construct the truth table for the compound statement and check whether the statement is a tautology or a contradiction or contingency. So we have three different statements, P, Q, and R. So the first thing, having three different statements means that we need 2 power 3, which are 8 rows as our base truth values. So we draw column for P with 8 spaces, 8 rows. So I have start with 4 T's followed by 4F. Q, 2 T's followed by 2F, 2 T's followed by 2F. And then R, TF, TF, TF in alternate manner. Then define the conjunction of P and Q. Define the statement not P. Define now the conjunction of not P and R. Define the conjunction of Q and R. So then now we can get the conjunction of now. We can now define now the overall statement given P and Q, or P or not P and R, or not Q and R. If you can't move from here to the final column, you can as well now create another column here for the statement P and Q, or not P and R. So create this column separately. And then now, once you have the values for this column, then you can always now combine them with the column for this Q and R using this disjunction. You can clearly see how this table is obtained. Because we have combination of both T and F, then this will be a contingency. Simplify the following. So I power 1729. So what just have to remember is that the imaginary unit I with different powers work in this cyclic manner. I power 1 is I power 2 is -1, I power 3 is -I power 4 is 1. So what we normally do, we now try to see how many times the power can be divided by 4. And when you get the remainders, of course, if you are dividing by 4, remainders can be 0, 1, 2, and 3. Then we can use now these smaller cases to know the reduced expression. So dividing 1729 by 4, we get 432 remainder 1. So which means then I power 1729 is the same as just I power 1, which will just be I. And then here is a summation from 1 to 102 of I power n. So the powers of I repeat every 4 in this manner. I minus 1, minus 1, minus I, then 1. So therefore, this sum can be grouped into complete 4 cyclic terms. So which will start with I plus minus 1 plus minus 1 plus 1. And when we add all this, we get 0. So the number of complete circles, because this will be 102 terms, so when you divide 102 by 4, we get remainder is 2. So the 25 complete circles will give us a sum of 0 because we're getting the sum here from this cyclic order. And then we remain with an I power 2. So I power 2, so the complete circle will be 0 to the sum, and the remaining terms corresponds to, now, because we have now I power 1 and I power 2. So I power 1 is I, and then I power 2 is minus 1. So when we put, when we combine them, we get now I minus 1. So define a relation R on A by this. So check whether R is reflexive, symmetric, antisymmetric, or equivalence. So we know that a relation R is reflexive if AA in R for all elements A in A. So we have all these 3, 1, 1, 1, 2, and 3, 3 in R. So therefore, R is reflexive because set A is having elements 1, 2, and 3. Actually, we needed to have actually given that A has or the set with elements 1, 2, and 3. And then is R symmetric? So our relation R is symmetric. If A, comma B is an element in R, then it must imply that B, comma A must as well be in R. So therefore, since we can say 1, 2 is in R and 2, 1 is in R, 2, 3 is in R, and also 3, 2 is in R, then R is symmetric. Then a relation R is antisymmetric if A, comma B is in R and B, comma A is in R, then A must be the same as B. So since we can see that 1, 2 is in R and 2, 1 is also in R, but 1 is never the same as 2, then R is not antisymmetric. So a relation R is said to be transitive if A, comma B and B, comma C are in R, then it follows that A and C must also be in R. So we can see that, for example, 1, 2 is in R and 2, 3 is in R, and we can also see that 1, 3 is in R. And also when you check for other conditions for the same thing in the definition of the transitive, you'll see that all the rules of transitivity are satisfied. So R is transitive. And the relation R is equivalent. It's an equivalence relation if it is both, if it's reflexive, symmetric, and transitive. And so therefore, since all the 3 conditions are satisfied, so R is an equivalence relation. Then in a survey conducted among the 200 adults, a researcher aimed to understand the preferences for different economic courses, microeconomics, macroeconomics, and international economics. The results showed that the following: 10 adults enrolled in all the 3 courses, 19 studied both microeconomics and macroeconomics, 29 studied both macro and international economics, 25 studied both international and microeconomics, 42 did not study any of the 3 courses. Based on this information, determine how many adults studied exactly one of the 3 courses. So let M represent those who study microeconomics, and then A, those who study macroeconomics, and I, those who study international economics. So since we have been told those who don't study any of the three courses, we can actually find the cardinality of the union of the three. So by just taking the total minus those who are not doing any of the three courses, so we get 158. So using inclusion-exclusion principle, then we have this formula, and we can draw a Venn diagram and label the parts of the Venn diagram. With the given information, we carve these parts as parts of the Venn diagram. So using the values in the inclusion principle, we clearly see that the sum of A, B, and C is given by 105. Then in the year 2023, a survey was conducted among the top 500 economics analysts. 310 had degrees of any kind in business, in economics, 238 had undergraduate degrees in economics, and 184 had postgraduate degrees in economics. So the first part, how many analysts had neither undergraduate nor postgraduate degrees in economics? This is a very direct problem because we have been given the total, which is 500, and we've been told that 310 are studying any kind of degree, postgraduate degree in economics. So to find those who are not studying any of the two degrees, undergraduate or postgraduate in economics, simply take the total number minus this 310, which is those who are studying any of the two degrees. So it'll be simply 500 minus 310 to give us 190. So 190 analysts had neither undergraduate nor postgraduate degrees. Then part two, how many analysts had both undergraduate and postgraduate degrees? Now, here, this question is very slippery. These portions of this Venn diagram, here we have 126, those who are in undergraduate class only. Here, 112, those who are sharing between those who are in undergraduate and those who are in having postgraduate degrees, and 72, those who have postgraduate degrees in economics. So when you want, remember that any person who is doing a postgraduate degree in economics need not necessarily to have done an undergraduate degree in economics. It is possible to do a different degree in undergraduate and then enroll for a postgraduate degree in economics. So therefore now, to find the number of analysts who had both undergraduate and postgraduate degrees in economics will just be direct way we obtain the intersection of sets. And so it'll be simply this portion. So we'll not include this other 72 because it is possible that someone who is in this space of 72 did a different degree in economics. So therefore, only this part will actually be in agreement with those who are both undergraduate and postgraduate degree in economics. And then how many had undergraduate degree in economics, but no postgraduate degrees? So it's very direct. This is this part, 126. And then how many had undergraduate degrees in economics, but no postgraduate degrees? How many analysts had undergraduate degrees in economics, but no postgraduate degrees? So it is still this 126. And then this last one, how many analysts had at most 1 degree in economics? At most, 1 means 1 and less. So this will be those who having undergraduate degrees alone and those who have neither. So it will be 126 plus 190. So remember, 190 is having 0 degree in economics. And when you say at most 1, then means that value 1 and anything less. So anything less, 0 is less than 1. So it will be part of that set. So it will be 126 plus 190. Then lastly, express sine power 4 theta in the form of this. where A, D, E, and F are constants. You can use this identity that sine squared theta is 1 minus cos 2 theta over 2. So which means sine power 4 is this sine squared squared. Then when you square this is what you'll obtain. And then once you simplify the numerator and denominator and divide through by 4, you should clearly say that sine power 4 theta reduces to this expression. And so you can easily pick out your D, your C, and your D, your E, and then your F. And then lastly, find the value of the real numbers x and y if the complex number 3 minus ix minus 2 minus iy plus 2i plus 5 and 2x plus into minus 1 plus 2iy plus 3 plus 2i are equal. So know that two complex numbers z1 and z2 are equal if and only if the real part of z1 equals to real part of z2 and the imaginary part of z1 equals to imaginary part of z2. So what you do, you expand the two complex numbers and rearrange the real parts and imaginary parts and then equate them. So equate this real part of the two complex numbers and equate the imaginary parts of the two complex numbers. Then form two linear equations using the real parts and the imaginary parts. And when you solve, you get x equals to minus 1 and y equals to 1. So that is, those were the solutions of the part. And please go through them and correct where necessary so that in case the same problems can be asked, you should be in a position to respond them correctly. Thank you.